Okay, for today's session, we will be discussing about the examples of quadratic equation. Last time, my co-reporters have discussed about the brief history about quadratic equations and also the formula or how to solve it. So let us proceed. As you see, these are the quadratic equation examples. Beneath are the illustrations of quadratic equations of the form ax squared plus bx plus c equals 0. So in the first one, x squared minus x minus 9 equals 0. So this is an example of quadratic equation. X is equal to 1. So as you can see, it has a degree of 2 and it follows the correct form, which is the ax squared plus bx plus c equals 0. So on the second one, 5x squared minus 2x minus 6 equals 0. So third one is 3x squared plus 4x plus 8 equals 0. So in the fourth one, negative x squared plus 6x plus 12 equals 0. So these are the examples of quadratic equation which follows the correct form ax squared plus bx plus c equals 0. So let us proceed. Another examples. These are examples of quadratic equations in which c is absent. In the first one, negative x squared minus 9x equals 0. As you can see, x squared is a, 9x is b. So there is no c. Can we still call it a quadratic equation? Yes. As long a is not 0 and it has a degree of 2, it is a quadratic equation. Again, b and c can be absent or they can be equal to 0, but a is a non-zero constant or cannot be equal to 0. So the second one, x squared plus 2x equals 0. Third one is negative 6x squared minus 3x equals 0. The fourth one, negative 5x squared plus x equals 0. The fifth one, negative 12x squared plus 13x equals 0. In the sixth one, 11x squared minus 27x equals 0. So these are the examples of the quadratic equation in which c is absent. So question, if a is present, b is absent, c is present, can we still call it a quadratic equation? Yes. Again, b and c can be equal to 0 because it is a constant term. But a cannot be 0 because a always matter and the degree of 2 matters. Okay? So this is a problem of quadratic equation. 2x squared minus 200 equals 0. How do we solve this? So the first one is to get rid of the negative 200. How can we do that? Simply add 200 on the other side of the negative 200 and the other side also 0 plus 200. Gets? So here is the result. 2x squared equals 200. We get rid of the negative 200, so what is left is 2x squared. And 0 plus 200, that is 200. So what is the next step? The next step is to get rid of 2. So how can we do that? So below the 2x squared, simply add 2, and below the 200, also add 2. So cancel 2 and divide 200 by 2. So what is left? The result, x squared equals 100. 200 divided by 2 is 100. Gets? Okay, next. The next step is to get rid of the degree, which is 2. So how can we get rid of the squared? So what we are going to do is we need to square root x squared and 100. Both sides, okay? So the square root of x squared is x. The square root of 100 is 10. So the answer is x equals plus or minus 10. So why is it plus or minus? This answer can be broken into two answers, which is x equals positive 10 and the other x is x equals negative 10. So gets? Okay, let us proceed. Another example. 3x squared plus 48 equals 0. Again, what we did on the last example, it's the same. So 3x squared plus 48 minus 48 equals 0 minus 48. So what we did is we need to remove or get rid of the positive 48. So to remove the positive 48, simply add negative 48. And also, on the other side, add some negative 48. Okay? So what is left is 3x squared equals negative 48. So the next step is to remove the 3. So how can we remove the 3? So simply add 3 under the 3x squared and the negative 48. Both sides. So here is the result. X squared equals negative 16. So 48 divided by 3 or negative 48 divided by 3 is equals negative 16. So next is to remove the degree of 2 or the squared. So what we are going to do is to square root both sides. Square root of x is x and the square root of negative 16 is negative 4. So the result is x equals x equals plus or minus 4. It can be broken down into two answers, which is x equals positive 4 and x equals negative 4. Gets? Okay, let us proceed. So which is which? This is supposed an activity, but I'm gonna discuss it na lang. So here are the general instructions. Identify and explain whether it is a quadratic equation or not. So in the first problem, 3x cubed minus 4x plus 5. Do you think this is a quadratic equation? Let us see. It is not a quadratic equation. The first term is raised to the third power. It must be raised to the second power in order to be quadratic. It is not a quadratic equation because it has a degree of 3. So degree of 3 is not a quadratic equation. It is a cubic equation. Again, a quadratic equation has a degree of 2 or it has a second power. Okay? So let us proceed. 5x squared minus 4x plus 2. Do you think this is an equation of quadratic? Let us see. It is a quadratic equation. The quadratic equation is in the correct form ax squared plus bx plus c equals 0. Again, it is a quadratic equation because it follows the correct form and also it has a degree of 2. The last example is not a quadratic equation because it has a degree of 3. This one has a degree of 2. Quadratic equation is a degree of 2. Okay, let us proceed. 7x squared minus 7x squared equals 49. Do you think this is a quadratic equation? So let us proceed. it is a quadratic equation. This equation can be rewritten as 7x squared minus 49. In this equation, b is 0, b or c can be 0, however, a cannot be 0. So as I mentioned earlier, a is a non-zero constant, b and c is a constant. So b and c can be 0, but a cannot be 0. So in this problem, what we did here is called, we need to transpose or distribute the 49 to the other side of the equals. So positive 49 will become negative 49. So what if it's negative 49? Then distribute to the other side. So it will become positive 49. So that is what you called transposition. So next. 2x squared equals 8x minus 3. Do you think that this is a quadratic equation? So let us see. It is a quadratic equation. This equation can be rewritten as 2x squared minus 8x plus 3, which would then be in the correct form of ax squared plus bx plus c equals 0. So what we did here is transpose 8x and negative 8x minus 3, and or distribute the both of them on the other side. So positive 8x will become negative 8x, and negative 3 will become positive 3. Then it will follow, it will show that it is in the correct form now of the quadratic equation. So that is all about the introduction of quadratic equation. I hope you learned something and can this lesson will serve as a guide for the upcoming discussions about how to solve the quadratic equation using factoring, completing the square, using the formula, and many more. So again, my name is Baron Alison Apuston. So have a good day, everyone. Thank you.